In this question, a continuous beam is supported and loaded as shown in the figure. The stiffness of springs are at B is EA by 20 and at C is EA by 30. If EA is the constant, what is the bending moment at support B? Bending moment at support B we have to find out. So from the figure that was given, if we apply the moment equation to span ABC, moment equation we have to apply. So MA moment at A 4 by 2 into MB 4 by I plus 4 by I plus MC 4 by I is equal to minus 6 into 21.33 into 2 by I into 4 minus 6 into 20 into 2 by I into 4 minus 6e into minus 20 RB by 4EI plus minus 20 RB by EI plus 30 RC by EI whole divided by 4. Applying in the similar way, applying three moment equation to span BC and CD. MB 4 by I plus 2MC 4 by I plus 4 by I is equal to minus 60 by I minus 6 into 9 into 2 plus 6 into 3 into 2 by 3 into 1 divided by I into 4 minus 6E minus 30 RC by EI plus 20 RB by EI whole divided by 4 plus 30 RC by 4EI. So from these equations we know that by solving we get RA is equal to 8 plus 0.25 MB in positive direction, RBL at left side, 8 minus 0.25 MB side, R at B on right side. Reaction is 5 plus 0.25 MC minus 0.25 MB in the upward direction. RC at left side is equal to 5 plus 0.25 MB minus 0.25 MC on upward direction, or reaction at C on right side is 2 minus 0.25 MC upwards, or at D is reaction at D is 6 plus 0.25 MC moment at C. So we have to find out moment at B. By substituting and solving we get MB that is equal to 10.138 kilonewton meter is going to satisfy the equations. So option A is correct. A plate load test was conducted in sand on 300 diameter plate. The diameter of the plate we can say is 0.3 meter, that is equal to 300 that was given. The plate settlement has 5 plate settlement SP we can represent 5 at the pressure of 100 kPa. The settlement of 5 by 8 meter rectangular footing, width of the footing F is equal to 5 meter, that is equal to 5000 at the same pressure will be. We have to find out the settlement of the footing. We know the relation for the plate load test is settlement of the footing is equal to settlement of the plate into width of the footing into width of the plate plus zero point 0.3 by BP into B of plus zero point 0.3 whole square. Here these has to be, the units has to be in meters and the units has to be in millimeters. So SF, by substituting these values, 5 mm into width of the footing, BF is 5 into 0 0.3 plus 0 0.3 divided by BP 0.3, 5 plus 0.3 whole square, that is equal to 17.8 millimeters. This is going to be in millimeters. So 17.8 millimeters. Option B is correct. We have to find out from this question. First we have to know. The question is, a cohesive soil has an angle of internal friction 25 degrees. Phi is given as 25 degrees. And the cohesion C is equal to 40 kilonewton per square meter. If the specimen of this soil is subjected to triaxial compression test, then the value of lateral pressure in the cell for failure to occur at a total stress of 400 kilonewton per square. The total stress was given as 400 kilonewton per square meter. So we have to find out the lateral pressure in this cell. Sigma 3 we have to find out. So in a triaxial compression test, we know sigma 1 is equal to sigma 3 into tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. By substituting these values in the above equation, we came to know that sigma 3 is equal to 111.38 kilonewton per square meter. By simple mathematical calculations, we will come to that value. That option C is correct. Says at a depth of 2 meters, that is depth of foundation is 2 meters under the ground, a rectangular footing 1 meter by 2 meter, that is width is 1 meter and length is 2 meters. The unconfined compressive strength of the saturated clay soil is 100 kilonewton per square meter. So unconfined compressive strength is equal to C is equal to cohesion unconfined compressive strength S by 2, that is 100 by 2, that is equal to 50 kilonewton per square meter is the cohesion of that saturated clay soil. We have to find out the net ultimate bearing capacity according to Skempton. So according to Skempton, the net ultimate bearing capacity can be calculated by CUNC plus gamma DF. The net ultimate bearing capacity QNF is equal to QF minus gamma DF, that is equal to CUNC prime. As per Skempton, NC prime is equal to 5 into 1 plus 0.2 dF by B into 1 plus 0.2 B by L. By substituting these values in NC, we will know 5 into 1.4 into 1.1, that is equal to 7.7. By substituting NC in this equation, QNF is equal to 50, Cu is 50 and NC prime is 7.7, that is equal to 385 kilonewton per square meter. That implies the net ultimate bearing capacity of the above problem is going to be 385. That is option C is correct.